Welcome back. This is part one of a series of videos about the classic Chrysler electrical system from the 60s and 70s roughly. You're looking at a early 70s B-body harness. Very similar. The E-bodies were pretty much similar to this. Some C-bodies, early 70s C-bodies use the same fuse box and a bulkhead connector, and circuits are pretty much the same. We're going to do a demonstration of some common issues, some misinformation about how to fix some of these issues, some drawbacks of some of these modifications that could be made, and get a little deeper into ammeters and where the current is flowing when the system is charging. But this is what a typical harness looks like, wrapped up out of the car. This one's actually in pretty good shape. Bulkhead connector, fuse boxes clipped to the back of it, ammeter wires. Charging system runs through this wiring, as well as some other circuits. That's a four-way flasher, brake light. It's an instrument light of some kind. Don't remember where that one goes. This is a standard dash B-body. Wiper switch, accessory tab. Orange is the illumination circuit. Grounding for the harness. There's a couple of items in here that need ground. Specifically, there's a ground in that guy for the cluster. A door jamb switch. Emergency brake, rear body harness, dome lights. I believe that's a seat belt. Warning system plug that makes this guy like a 72 or a 73 harness. Window dimmer switch or high-low select. Turn signal, ignition switch, wiper switch. Don't recall exactly. That's a light buzzer circuit of some kind. There's another accessory tap. That one's keyed. This one is not keyed. Red is unswitched power. Turn signal, flasher, illumination, cigarette lighter, power supply. Yellow is the switch ground for the door for the door pin switch, passenger side. Seatbelt buzzer, I think that is. It's a buzzer of some kind. In any event, this is what it looks like in its original state right out of the car. And we're going to take another harness and show you some things. Okay, this is what I call the fixture. It's the exact same harness you were just looking at, but this one has been unwrapped, obviously. Every circuit in that harness that is protected by a fuse has been removed. What you see here now are all the wiring and circuits in that dash harness that are not fused. They are not protected by a traditional fuse of any kind. These all depend on fusible link at the battery or at the starter relay to the battery feed. We have a stand in here. I don't really feel like replacing a bunch of burnout 16 gauge fusible links because I intend to do some measurements here and it could get destructive. So we're going to use a fuse, and we're also going a 16 gauge fusible link. It's probably worth about maybe 35 amps, something like that, before it should open. It should open before any of these other wires burn in the event of a short circuit. It's called circuit protection. Any electrical circuit to be deemed to be safe needs circuit protection. Things happen, wires short, wires get pinched. Somebody does some poor replacement connections, leaves some insulation off, something touches it, somebody sticks a ratchet on the alternator stud without taking the battery cable off, and now you have a short to ground. And if it touches the body or something along those lines, there's many things that can happen here, but what you don't want to see is the wiring burn. If you get enough current flowing, you can light up this wiring pretty quick and much faster than anybody can react to a smell of any kind. This battery has hundreds of amps of potential. These loads include ignition switch. All of these switched loads with the ignition is on, no fuses. Headlight circuits. There is a circuit breaker within the headlight switch that protects this 16 gauge wiring running out to the headlights through the bulkhead connector. But that's it. It is being fed by unfused power from Splice 1. Some of the tools that we're going to be using, I'll introduce you to if you don't know what they are, so we don't have to do this on all the videos, upcoming videos. This is a multimeter, for those who may not know. It's called a multimeter because it's also an ohm meter, a voltmeter, and an ammeter, or measuring current. This is another ammeter. I believe this does volts too, but we're not going to mess with that. I think it's got some leads on the bottom for volts. Ammeter, ammeter. This, for those who don't recognize it, is a battery load tester, also referred to as a carbon pile load tester. Literally, it's a pile of carbon discs that get clamped together at a variable rate to essentially become a variable high-powered resistor. We're going to use this to bring some variable loads going on here and see what happens to this factory wiring. Some of the videos I'm going to do do not involve load testing this wiring, but one for sure will. We'll save that for the last because I'm pretty certain there's going to be some damage done. Standing in for the alternator for these videos is an Astron 30 amp power supply. Operates at right around 14 volts. It has its own ammeter to display what is being pulled from this. We don't have that connected yet, but we'll add that into the alternator stud when we get in there and do some measuring. We're also going to watch temperatures, resistance, and current flow create heat. We want to see where that heat is at. Oh, this will be part of one of the videos, the shunt wire. Over on the other side, we get battery, 800 cold cranking amps, a standard Optima. Our headlight loads running off of the same configuration that the factory uses for their lights. The bulbs themselves would not be considered stock for 1972. These are actually sealed beam halogens. Stock sealed beams would not pull anywhere near what this current is, but we're using these for a higher current load so we can speed things up here and see how it behaves. Standing in for the instrument cluster is a 1971 through 72 Rally non-clock tack extra frame that I have here. You'll notice there's more than one ammeter going on here. One of the videos we're going to do some ammeter testing in comparison with. As mentioned, stock headlight switch, stock wiper switch. The wiper switch is only here to represent that it too gets keyed power. that only is protected by the fusible link. That's about it for the fixture. When we get into the actual subject videos, we'll dig down a little deeper into what we're looking at here.